Я бы сегодня хотел рассказать вам, почему это важно выделить Python как отдельное средство для разработки высоко нагруженных приложений, особенно тех, которые должны работать в реал-тайме. Ну, начну с того, что давным-давно, когда каждый второй студент хотел сделать какой-нибудь свой сервис, который в будущем масштабируется и побьет Google, при мыслях о масштабировании возникали, как правило, очень неправильные мысли о том, что если приложение будет очень high-load и real-time, то Python здесь не годится почти сразу, ну, из-за дефолтной однопоточности, из-за не очень высокого перформанса, но это не так. Есть ли у Python какие-либо преимущества, которые покроют все остальные недостатки? Ну, конечно же, есть, иначе бы этого доклада не было. Да, перформанс данного языка немного ниже, и даже не немного. Но это очень сильно компенсируется его выразительной мощностью. Я попозже чуть в больших деталях опишу, чтобы не быть голословным здесь, что за собой ведет уменьшение количества времени на решение проблемы. Это, соответственно, удешевляет разработку, делает более дешевой добавление новых фичей в проект, также, естественно, упрощает поиск ошибок. Про перформанс, да, действительно, он ниже. Есть достаточно много работ, которые показывают очень наглядно, что код, написанный на Python, я говорю сейчас про классический C-Python, конечно, заметно медленнее, чем нативный код. Есть вот работа Претчета, очень каноничная, которая показывает среднее время исполнения. Здесь, обратите внимание, шкала логарифмическая. Это некоторые бенчмарки, запущенные на различных компиляторах и интерпретаторах. У Python, как правило, и разброс больше, причем начинается он от 4х и заканчивается где-то там, почти в бесконечности. Эти данные, естественно, не уникальны. Вы можете очень легко их проверить и из эссе Гвида ван Россума на Python.org. В Benchmark Games есть свой сет бенчмарков, которые делают примерно те же самые сравнения с примерно теми же самыми результатами. Также сама архитектура предполагает ограничения по векторизации кода. Это решается, естественно, сторонними библиотеками, но сейчас речь не про них. Про байдинги поговорим немного попозже. Компенсируется это, естественно, выразительной мощностью языка. В одной из тоже каноничных книг на эту тему было посчитано, что примерно одна строчка строчка кода на Python делает то же самое, что 6 строк на C, ну, что, соответственно, делает этот язык намного более выразительным и позволяет разрабатывать намного быстрее, думая, собственно, о логике приложения, а не о логике самого кода, управления памятью и вот это вот все. Также ясность кода, его читабельность очень сильно добавляет очков выразительной мощности этого языка. Соответственно, сроки разработки, они пропорциональны выразительной мощности в обратной пропорции. Ну и production cost, соответственно, сроком разработки пропорционален. Также я однажды задумался на тему, а можно ли вообще как-то обфусцировать код, который написан на Python. Это ни в коем случае не связано с кодом компании, я никому не рекомендую это делать, но оказалось, что почти невозможно. Это данные, скомпилированные вот этим автором, Корнели Бернсом, из двух работ. Одна из них, собственно, Претчет, другая Гаррета. Из данных, представленных выше, среднее число часов, которые затрачены на решение какой-либо небольшой проблемы в Python, оно в несколько раз ниже, то есть порядка 3, тогда как на C++ оно порядка 11. И среднее количество строк кода, я как понимаю, речь идет о небольшой функции. Ну, для класса это явно маловато, но на функцию вполне себе похоже. Каким образом проводилось исследование, он не раскрыл в своей работе. Ну, таким образом, есть преимущество.
So, there are certain advantages due to which this language is really quite worth using in such applications, but I wanted to mention a number of issues about it. First of all, you should all understand what is the high workload mean. What we mean by high workload is 300,000 to 400,000 at a time. It's just the average number. Normally, if it is just a normal day, it is about 10 arenas that are closed. So, in fact, it means if it is 10 arenas per second, it is a very resource-intensive task for our application, because at that very moment we distribute the experience, the awards, and everything should be saved. That is to say, in this case, we shouldn't have any failures, because if anything should happen, and then there will be a lot of dissatisfaction on behalf of the player, of the gamer. And then during the battle between the client and the server, around 10,000 events per client are sent. And it is all the events that go from the server to the client and from the client to the server, including all the minor moves of the gamer. All of these minor things are sent to the server, and the order of this, the magnitude of this value is quite high. If any of you would like to carry out a stress test, then you could use a light tank. Then, for instance, using a submachine gun, simulating the events. In this case, it's possible to increase the number of events, and the server would be able to digest it, so to say. At this moment, these data are outdated, and in 2013 it was 815,000 events, but in 2015 it was over 1 million. And here are some more statistics, specifically per week. As far as the number of unique visitors, it is rather related to marketing, because the gamers play simultaneously, but it is for the EU cluster, which is not the most loaded one. So, here, I hope we have synchronized the terminology, what we mean by high workload and real time. And now let us look at the problems that may arise if we write all the logic on Python. Here you can see that practically all the logic is written in this language. There is a number of libraries, and the physical features are calculated separately, but all the logic, including all the events during the battle and the actions by various gamers, or everything that is shown, or everything that happens in post-battle too, will be simultaneously digested using the systems described in the previous slides. And the server and what may happen if there is a mistake? In a normal case, nothing may go wrong, but we prepare, we write an application which is performed in real time. Then after one quant of time, it should be regenerated for all the gamers. They should be updated. They should accept all of their data and issue their coordinates minutes, who should see whom. We do not send them as raw data to the client. We only send to the client the data which is intended for the particular game client. The other data will not reach the gamer, but it applies more stricter requirements on the server. So we use the network, and in this case there is a problem with the use, because if we were to use Python in a straightforward manner, then it would have been different. But it is not monolithic, and there is interaction between various problems. If one of the things fails, then normally the server would like to stop operating, and then therefore if one of the processes fails on the side of one of the gamers, it means that that gamer would be left unattended, which is unacceptable. We know how to process such events so that this gamer could get back within a minimum time. And so let us now start with real time. Real time, to ensure real time using Python, we need not only language performance. Let us assume that we have a certain time quantum. In our case, it is 100 milliseconds. And to send the updates, we need to calculate all the parameters that have come from the client. And then we should give them the new values of all the gaming parameters. And we should do it with a certain reserved time in order to have time to send the data. But we have the flow blocked by certain code pieces, and then all of a sudden a certain software program wants to work longer. I don't know why. Then in this case the statistics will not be gathered, we won't have time to distribute updates, and we'll have a spike, which means that the game apparently does everything correctly, but
the hardware is not good enough because this particular type has been missed. This is the event which, to a greatest extent, exponentially will irritate the gamer, because he does his best, he's doing his best, and for certain reasons the game becomes worse and worse, or the results become worse and worse. And what should be done? First of all, in this particular game, we have this so-called preemptive multitasking, which manifests the following way: 100-bit code instructions in Python 2. It is a norm for an application, for an ordinary application, but we are restricted with time. So if you wait for every 15 milliseconds in Python 3, we don't have time to switch between different tasks, and we cannot be preemptive in terms of a particular task for all the parts to get the updates, apart from one which becomes longer for a certain reason. This is an interval value, and it is available for the user to read and modify using the Python API. There is a method which in fact is attached to it. You can have smaller or bigger values, and generally speaking, the diphobic and we are also restricted with a tick, and with a maximum number of cells it will be dispatched to clients. But it's not that easy. If it is only it, then we will reduce it, and that's it. But the majority of functions, nonetheless, in Python libraries, and here we have the interval. We use the code which is performed separately in a physically separate volume or flow. It can calculate the physics, and from very big modules we have physics and render. The render clinity, in fact, and in the server we have the physics. If the same problem comes in the third-party code, then we cannot resolve the problem just actually attaching the gel, because we cannot actually control the code this way. And there is no evident solution how it can be done by means of a Python, and it cannot be done. And as the code, in fact, is done by a separate designated solution that we trust the performance in, we are not going to tune up the Python itself. We are going to do the gatekeeping, the reviews, also the performance tests of the code should be run, which will definitely. The most important solution here will be the external one, and the Python seems to be not included. But if we speak about the very important solutions, then actually it's we have the performance block. What should be done with it? Nothing could be done with it. Actually, we just switch it off, and the reference counter continues working. You cannot just switch it off, and you cannot use the garbage collector, and you cannot actually restore the memory, but the codes are performed, only the ones that are trusted. There are no external code, and that is why we have very high level of reliability to our code. There will be no cyclical batch problems. We can forget all about it, and this is one of the Python instruments which, in such high-loaded applications, it will give us the first time, so it will actually break the real-time instrument. Let's come back to this slide. What can actually go wrong further on? Of course, the network usage. Why and how is it collected with the Python? A couple of years ago, there was a speaker who talked about the network code and how actually it was rewritten in a different division, and you can find it in the PiterPy archives. I'm not going to go deep into the network itself, but we shall be talking about what actually comes to the network from the code. We have great number of variables which are not typed by the architecture, by the Python architecture, but we need information about the type of data, type of these variables, to pack them somehow, to optimize them within the network, to optimize the network usage for the proper and fast unpacking, and also we use them for the database effective usage. How all these things can be solved? It is quite evident. So, for instance, let's consider these variables to be typed. This information can be stored separately. For instance, this is a simple mock of packer class, which will try to pack the results. For instance, we need to dispatch certain result bulk data to a client or some other entity, and we claim all the variables. We claim the default type, the default packer, the default value, and also what should be done if there was a sudden overlap of the range. So all this information is here, and we have to take this into account, otherwise there will be an exception. But this exception is something that limits us, but we need it on the other hand, because from these particular range, we need to do something to create something that that the network receives, not the charts and lines, but something more compact, which can be unpacked at that at the other end of the program. It can be C picker, and then we pack it. Later on, this particular glossary will be packed, and we are going to pack it also in a short array. Thus, there will be even more packed data to the DOM. But there are lots of packers like that. Why not use just a marketed solution? There are historical reasons for that on the first hand, and it's quite an old project. The company is actually 20 years ago. Big World Do is even more advanced, and so to say, even more aged. And from the contemporary packers, we didn't find a single solution that would be applicable. Also, many of them process in such a way that we cannot optimize the data flow, which is really needed. If there is a very long data, if we optimize it, we say that everything is zeros. But if in the fourth cell there must be some variable, then in the majority of standard packers, at least at that particular period, we needed to send all this. Creating our own packer, we can optimize the parameters that we need, and also at the end of the list we can place the less important parameters which are not important for the client. But the most important will come in the very beginning, so the length can also be variable depending on what exactly is happening. But this is how we store the data. This is the database. So in the previous example I showed how we store data for the packer. And here, I suppose that everybody is aware of these particular schemes. For those who find it new, you can find also the how we communicate with the game engine, whether it is persistent or not, the type, and some flags. And I suppose that we shall come to it a bit later. Apart from the network and the real-time, let's talk about stability. Generally speaking, as a matter of fact, inside of the server, we send the data between classes, and in the classical case, it looks this way. So there is one entity which calls the other entity, calls some method upon it, and it does something, doesn't matter what, and it sends it back with a callback, probably, when ISNTO did not exist when we started, when we just initiated the project, and that's why the variability is quite big. And what can go wrong again here with the stability? It's an entity that can disappear, it can be lost, and there will be an error. As a response, just an application will show you an error, show you that something should be done again. But it's not good for real time. That processes data from a number of different gamers. Subsequently, if we find something like this, then the server, why did I add something like that? And I added it to the talk about the Python. First of all, we have a modified Python, which runs with the game engine, and there is one single platform that cannot be seen separately. And generally speaking, we should forecast the restoration of this entity for it to appear again in a full-fledged fighting condition. And I probably talked about it a couple of minutes ago. For each of these entities, we need to claim the parameters which should be persistent, that should be permanent. These are the parameters that we can get when the entity falls or drops, and they must be restored in any case, in any way. In any case, excuse me, and they must be definitely very convenient to operate if the entity is lost. and we should restore the function that disappeared. And for each of the classes, we need to provide a method of restoring the class. If it is done, then we can be pretty sure that if some of the classes is lost, it will appear again, and this code will continue working. As a matter of fact, as if it disappeared just a second ago, not in the beginning of the fight, of battle. So, subsequently, Python have some issues to be used for high load and real-time apps. We have some problems. We have some issues that require separate attention, but they are not worth for actually switching from Python to something else, like GL capture control, non-Python calls, performance control. Then if we have some rubbish source, we need independently localize it and liquidate and just get rid of it later on. We need to store somehow variable types, and we have to process them as if they are typed. These problems, they can be solved. In the first case, it's quite evident. You just tune it. In the second case, the Python cannot help us, and we need to somehow manually monitor it. And the great value of the Python, which I talked about, they actually mix the problems that can occur in such applications development, and it's really worth it. Thus, I would like to thank you, and I do hope that some of these cases will definitely be of good support to you if you want to develop something like that yourselves. Any questions? Thank you very much for the talk, and now it's Q&A time. Great many thanks. Could you kindly tell me, what do you use for looking for leaks in memory? Well, you know, the native code and its profiling is used, but not by us, because I actually use with this. I work with a server. I'm a part of a server team, and the server team uses Python. And there is another team that controls the memory and all the leaks. We also control it. We keep it under control. We have quite a serious quality assurance division, which will never miss just a single line without regression testing, memory testing, performance testing, and we have tools and instruments which we can rely and which we can rely upon, and look at the parameters which can be sometimes higher than they must be. If we do observe such situation, then we correct the code. We try to find the reason for that, and of course this code will not go into usage. Yes, thank you. Thank you very much for the talk. I have several questions to you. First one, I have seen vacancies from the Wargaming on Rust. Do you use Rust actually? Just connected with Python, or you actually talked about the codes, and do you use Rust or not? Well, you know, we use many sort of things, but the server uses Python network, and you saw vacancy in Wargaming. Then what is the project? Because we have many of them. I work in the world of tanks. We also have the blitz tanks. We have the battleships. We have airplanes, and we have other game lines. And there are other games which are quite niche ones, and they are multiple, but they're not very popular. And each of the projects, as we usually use the big world engine, and each of the projects is developed by a separate team for the server and separate team for the client. Maybe there are vacancies there or in the web, which provides the transactions, the purchases. They are in charge of a separate team, maybe somewhere there, but only the server team. That's for sure. Okay, thank you. What kind of Python do you use? Most probably Python 2. I talked already about legacy, and this is a very old, almost obsolete project. The first reminder of it as an idea was in 2008, 2009, in fact. It was already version 1. The Big World engine, in fact, it's even older than that. And I'd like to say that it's Python IPI, which was developed for Python 2, and actually switching to Python 3 and rewriting it for the whole bulk of data is not reasonable, and it's not possible. There are some legacies which we have to entail with us. And the Blitz, for instance, such projects, the Blitzes, they unfortunately they are stripped of that. But they can actually be used and started, but this is the decision of this person who does it. You actually talked about the Jill and real-time and the garbage collector. So whether it's easier to rewrite it for...
Ну просто вы сказали, что вот у вас есть там свежие проекты, в которые вы не
some fresh projects where legacy is not entailed.
Запилить вообще там гоп, просто уйти от Python.
You should step away from Python. Yes, that's a good idea, and everybody has this idea. But it's not possible. In bigger projects, it is not supported by the engine, so we need to use the engine, the Python anyway. So is it just the financial matter? Yes, it's just very expensive. It's the game logics. Apart from the modified Python, there is also tons of codes of the engine itself which will need to be revised and rewritten once again. So actually it's not reasonable at all. I see. Dmitry, hello. You are talking about the modified Python 2.7. Do I understand it correctly, that it's modified at the C calls and C libraries level? Yes, it is. And how do you evaluate what is the volume of team and how many years of experience that make this high load and thus modifications reasonable? That's a good question. If this question is addressed to a project manager who assesses the man-hour and does it professionally, then he would answer much more precisely. But I would like to say that when I came to the project, it looked already like this, and most probably it's reasonable if you create your own engine. For instance, you create your own engine and you write a Python API to it. And in the process of work, you can somehow adjust and tune the initials of Python, and you will actually receive a different code which will be working with this API. If you are not creating a new engine, then this small tuning, it is reasonable always. But actually, like switching off the garbage collector, it's one line of a code. And if you switch it off, and if you don't actually ruin the memory inside, then that means hours and months of working. So it depends on what kind of platform and how deep you go. If you start working with a ready engine, pre-prepared engine, then it's not reasonable, of course. Thank you very much for the talk, Sergey. Now I would like to ask you about the load, 850,000 sorry, just users, and well, it's a question about, it's quite a complex question, because there is no one monolith server. The cluster is a center and the periphery, and depending on the load, it is distributed over a quite big number of servers, and it's all done dynamically, and all these parameters are restored by a deployer. So I'd like to say that this is the figure, which are these are dynamic parameters. I cannot quote them now. Okay, and what about you use CPI, and what about the tuning? You understand that tuning can be you can tune actually this call for library and so on, but what about the insights and the structural part of Python's? Yes, exactly. We, for instance, have in our Python our own implementation of the dict, fixed dict, not the usual dict, because we cannot actually expand it Python-like. In a Python mode, we have our own array, we have our own data types, and all of them are tuned under the boot, so to say. We use the twister, and the asynchronous frameworks are also used, but also we use our own customized code. It's a twisted, but not only. And you use some asynchronic codes at the interpretate level, or the biggest volume of work is the engine, which is developed under the interpretator. In the interpretator, we also tuned it, and we developed types and subtypes. We also tuned a little bit the libraries. As they are modified a little bit, we cannot just update them easily. So you are going to use Python 2, you are not going to use Python 3. There will be no Python 3, most probably yes. I see. So these are the main questions, and I would like to hear a little bit more about the class restoration. Is it within the Python? Or do you just restore the service of the server? How you restore the entity if it disappeared somehow? This code is something that is called by the server. We have quite complicated class interaction. Each class has its own entity, and base up on cell up on client, and only the engine knows that these different classes in different processes and different machines are one single entity, and the data inside should be mirrored. This is the information which is not within the Python interpretator. It's done at the level of a server. Thus, it results in a number of complications. For example, you cannot take from one class and call the method of a different class. You should, first of all, ask the server. It will be accessed to another entity which is inside another machine, and this is how you derive the data. This direct call, it's when one entity is in different apps, so all the modifications are available at the level of the server. So only server knows that one in the same class lies within different machines, and what are the variables that should be synchronized between them. Thank you very much for the talk. Unfortunately, the time for questions is over, but that doesn't actually mean that you cannot address the questions backstage. We have a separate zone for Q&A at the entrance of this room, and you can ask Dmitry all the questions that you wanted but had no time to ask.